Okay, I'm go over resonance structure in discussion 1, week 1, question 4K. So use my chart on note 2. What's wrong with this and this oxygen? I'm asking what is missing. Yeah. Okay, so what electrons were missing?
2 lone pairs on oxygen.
Let's ignore this carbon chain here.
Here?
And 1 lone pair on oxygen.
Good. If you have problem with why I put 2 lone pair on this, you should open your note 2. There is a bottom chart with something like carbon, nitrogen, oxygen. What's the charge 0? What's the charge positive? What's the charge negative? Okay. So this part, oxygen is 0. In this case, oxygen is bound to 2 different things. That's a pair of lone pair. And oxygen is with 1 positive charge. Okay. When it's bound to 3 different things, you're missing a pair of lone pair. Are we good? Okay. Now, if I push here,
This is like its own thing, and then we just plop it into this bigger thing.
are we good? Do I need to explain any of the? I can slow down. I just did it just like yes.
So I guess something that always confuses me is if I do the 2 arrows, right, like moving that double bond onto the oxygen, and then moving that electron pair to make a double bond, you miss out on 1 resonance structure.
Oh, okay.
Right. Where it's like just the just the oxygen, and that one stays like the same, just 1 arrow at a time.
Okay, I can do 1 arrow at a time. Meant to show this is the process, but we can do here and we go back to check if there are more resonance structure. Okay, so that's from me, that's the most common way I would draw. It's one very similar to the acetate example in my class, right? My acetate is just, this is negative. And then 2, after we draw this, okay, we'll draw the resonance like here. Here, here, and then here. Okay, so that's 1 resonance structure, right? The one that you said was kind of like, I would check like this way. Like if I have this one, push it back. So if I have this one, push it back, is the structure you are saying?
Oh yeah, yes.
Okay.
And there'll be a plus on the carbon.
Yeah. Okay, it's the same that if you stop this arrow here. Okay.
I guess 2 things. The first one is I saw on a video that you can't have 2 arrows. Like it all has to be like linear. It can't be like 2 arrows connecting to 1. Is this fine if I were to like have 2 arrows?
You mean
like that?
okay? The only wrong thing is you cannot have this.
Okay.
This carbon cannot. This is wrong.
Well, I guess I was talking like, can I have 2 arrows? This is like the main one, and I have like 2 arrows pointing from it. Do you have to have it like 1 arrow at a time?
Not necessarily.
Okay.
Yeah.
And the second thing I guess was, is it like, would I be wrong if I don't show this structure? If I just jump from here straight to here?
It would be wrong for quiz 1 because we probably will ask you to show all the possible resonance.
Okay.
But in the future, this is more useful because we will kind of like, okay, the point of drawing resonance now is we are too early to learn mechanism. When we learn mechanism, a lot of the stuff we cannot do on this one. But once you draw the resonance structure, you can go from here to do the mechanism. So that's the point, okay? Yeah. Yeah.
For this question, which one would be considered major? Because the rule number 1 is to make sure they have an octet. Is it more important for carbon to have the octet or oxygen?
Basically, you want all of them. So now do the counting of octet in this case.
Like which one has the most filled
Yeah.
octet?
Yeah.
What if like 2 examples, they both have missing octet on one of them. On one of them it's a carbon and one of them is an oxygen. Do we know like
Then you can move on to the next rule. Yeah. So
Okay.
yeah.
Wait, what do you mean move on to the next one?
So you start to see the charges. Rule number 1 doesn't work for both, right?
Uh-huh.
Then you move on to the next.
Oh, the charges? Okay,
Yeah.
okay.
Do I need to show how to count? I can show how to count. Like, for example, this oxygen. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8. This oxygen has octet, right? Okay, this oxygen. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen is also good, right? This carbon in the middle is also good. Am I good just... Okay, the carbon in the middle, 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay, so this is all octet, right? These 2 are basically same structure. I'm not sure if you can see that. You good? Okay, that one, what's wrong with this one? 1, 2, 3, 4, 5, 6, right? So this one is minor. Okay?
So those 2 are equivalent.
Yeah. Are we good? No? Okay, where's...
Well, I didn't follow. I didn't see.
You couldn't see? Which
After
one?
you counted the electrons, what did you do?
Okay, we can count this again. It's the same thing, okay? I count oxygen. Did you guess the oxygen? I'll count carbon now. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Okay. I'll do a really large one on this. I might could erase this one, but I'll draw it with this. Yeah,
I guess just a quick question on this one. For like partial charges, when you do the hybrid for these, I guess for this one, in like the discussion manual, even though like for example on this one, there's a resonance structure where the carbon has a positive charge.
Yeah.
But then in the discussion manual, the hybrid wouldn't have a partial positive on that carbon.
So the hybrid meant to, that's 2 different things. So the hybrid is kind of like we want you to know. So don't worry about hybrid will be on your quiz because I don't think that's the case. It's more or less like hybrid. We want you to know. One of the hybrid I believe is showing like this, right? Is we want to know those. It's kind of like a single bond, double bond keep changing. So there isn't. That's kind of like the fact of the resonance. Although I draw 3 different structures of this same molecule, in reality they keep changing. They keep changing, just like they keep changing. So there isn't a really second that it looks like this. It's keep changing from double bond to single bond all the way. That's why we use this hybrid. So that's more like the fact. That's the only thing. Yeah. It's kind of like the one that I show in the class, O minus, O minus. One of them has one of them have double bond, and then you keep doing this. So it changed from here to O minus here. So it's okay. This CO bond, is that single bond or double bond? Theoretically, it should be one bond with a dash, and this one negative charge is on oxygen A or is on oxygen B. No, it should be keep jumping between oxygen A and B. The fact of resonance, I kind of like go over that in the previous office hour as well. The fact of resonance is you have one negative charge, okay? The fact of resonance is you have one negative charge. Is keep jumping here by bringing the double bond into here and bringing back. So the reality of the resonance is keep, the fact would be it's keep changing between this. But there's, if you always going to write all the resonance structure, it's not the case. So we will just say, okay, this looks like this, and we put dash line here, and we put a negative for total, means they keep changing in between. That's why we introduce hybrid. It's kind of like you should know none of these are the real. It's they keep changing this. Are we good? All right. I will erase part of this, and we'll count how that carbon is 6 stats. Then we're done with this one. Are we good? Okay. So that's the resonance I just erased. It came from here by not pushing this. Okay. It came from here by not pushing this. Are we good? Okay. 1, 2, 3, 4, 5, 6. Right? Okay. All right. I can post the video, I guess. Okay.